Good morning. Thank you so much for the invitation to join you here and to share some of the work that I've been doing both at Harvard now as an assistant professor and previously at MIT as a doctoral student. So the title of my talk this morning is Computational Creativity: What Kids Learn as Designers of Interactive Media. And I wanted to start the morning by sharing with what I'm obsessed by. So I'm obsessed with what people do with computers and what they could do with computers, but I'll start with that first question. So I spend a lot of time talking with people about what they do with computers, and this might not be surprising in general. They're spending time watching videos on YouTube. They love to play video games. They talk a lot about participating in social network platforms. But in general, they're surrounded by computational media, but they participate primarily, if not entirely, as consumers of this computational media, rather than as producers, as creators, as designers, which is something certainly where I was a graduate student at the Media Lab, we took for granted. And I assume this is a crowd that also kind of takes that for granted. It's a group of people that is mostly fluent with reading and writing computational systems. So what is the problem with this? Well, it leads to a certain sense of helplessness. And one of my favorite psychologists, Albert Bandura, who's currently at Stanford, but is Canadian, he was born in Alberta, expressed this in 2001, and I think it's only more true today. Everyday life is increasingly regulated by complex technologies that most people neither understand, and I think this is the most interesting part, nor believe they can do much to influence. So how do we change this feeling of helplessness? One way of regaining control is by learning the language of these technologies, by learning how to code. Code is the way of writing our computational world. And there's a fair amount of momentum, cultural momentum, around this at the moment. With initiatives like Codecademy's Code Year. And I assume this made the rounds here, the code.org video. So this is Hadi Partovi's code.org initiative. He commissioned this video. He's also organizing an Hour of Code event later this year. He's going to try and get everyone on the planet to code for an hour. So Hadi I sort of think of as like, and obviously Codecademy, I think of as sort of the tech crowd, computer scientists, engineers, programmers. But this isn't just a preoccupation of the tech crowd. Literary critic Catherine Hales in 2005 argued that we cannot afford to ignore code or allow it to remain the exclusive concern of computer programmers and engineers. Media theorist Douglas Rushkoff in 2010 argued that programming is the sweet spot, the high leverage point in a digital society. If we don't learn to program, we risk being programmed ourselves. Most recently, humanities professor Kathy Davidson described algorithms as the fourth R, accompanying reading, writing, and arithmetic. She said the fourth R provides an alternative to fact-based mastery and proposes instead iterative, process-oriented, constructive, innovative thinking. And so my argument is that fundamentally this isn't something that's just for some kids. It should be for all kids. Everyone should be engaged in learning how to read and write our computational world. And my argument isn't that everyone needs to be a computer scientist, not everyone needs to be a programmer, but everyone should have an appreciation for the thinking and the practices involved, the types of things that you all do every day. So that's very easy to say that everyone should get on board with this, but how do we actually do it? How can we support kids' participation as computational creators? Part of the story is about access to tools, and there's a long history of this at MIT. This is going back to the late 1960s with Logo. How many people had a Logo experience at some point in their lives? Okay, that's not okay. Sampling of people have had an experience with Logo. So my advisor is Mitch Resnick, who's at the Media Lab. His mentor was Seymour Papert, who's one of the developers of Logo. And so Seymour had this vision that kids should be able to use computers to express themselves and to explore ideas. So Logo had a good run, late 70s, 80s, even into the 90s, but it lost some of its cultural relevancy. So fast forward 40 or so years, and the Lifelong Kindergarten Research Group at the Media Lab, led by Mitch, has developed a tool that builds on this tradition. So maybe some of you have seen it, Scratch. So Scratch is a free programming environment that enables young people to create their own interactive media, stories, games, animations, and you build projects by snapping blocks together, just as you snap Lego bricks together in the physical world. So here I'm just building up a little program that's making the cat dance back and forth. So the cat moves 10 steps, plays the cowbell, because you can never have too much cowbell. You move back 10 steps, you play a different drum. Every time I click, the code executes. I can repeat the little dance, so I'll have repeat 3 times. And then I can make my project interactive by snapping on a when this sprite is clicked block on top, and every time I click on the cat dances back and forth. There we go. I've built the project. So again, partly about the tool, but it's also about having access to others, having access to a community. So the group developed a YouTube-esque space where people can share their projects with others online. You can view projects and interact with them. This is an interactive keyboard. You can also see inside projects. So there's a button in the upper right corner that says see inside, and when I click on that, I'm immediately brought to the code for the project. So you can study the code, you can then remix the code, and then share your remix back to the community. So when I told members of the MIT Scratch team that I was coming to this event, they're like, shut up, that's so awesome. And they told me that if nothing else, I had to tell you that the entire 2.0 site is powered by Django. So thank you very much for that. So let me tell you a little bit about the participation in the online community. So as I mentioned, it was launched in 2007. The members are mostly between the ages of 8 and 18, and there are some younger kids who are participating, and there are some older kids who are participating. We've got a large adult hobbyist community, so there's a long tail. 37% of the participants self-identify as female, 63% as male. And people are participating from all around the world. The Scratch interface has been translated into more than 50 different languages. So what I wanted to share with you today was what kids are doing with Scratch and get a little bit at the question of, so what are kids learning when they're engaging in an activity like this? And I wanted to share 3 major areas of the learning. Computer science concepts that kids are learning, sort of design and problem-solving practices that they're engaging in, and then psychological, social, and technological perspectives that they're developing or that they're learning. So let's start with sort of the computer science concept angle first. So by working with Scratch, kids are learning about sequences. This is a very powerful idea for an 8-year-old, the idea that you break down a problem and you specify what to do step by step. Loops, parallelism, events, functions, variables, conditionals, etc. I could keep going, but what I think is more interesting is why they're learning it. And I wanted to motivate the why of their learning with a metaphor. When talking about Scratch, we often use the metaphor of a room. So it should be really, really easy to get started. So we talk about having a low floor or a low threshold. But you should also be able to create arbitrarily complex things. So you should have this high ceiling, so low floor, high ceiling. To further abuse the metaphor of the room, we also talk about having wide walls. So you should be able to create whatever you want. You should be able to create a wide range of things and connect to what you're most passionate about and what you're most interested in. So kids, the connection to this is kids are motivated to learn about and use computer science concepts because their personal passions and interests are situated in a meaningful context. So generally, computer science education has a really bad reputation for supporting personal interests. And I think about this in relation to my own experience as a computer science major. So we're going to get in the time machine. We're going to go back to 1997. And this was my very first programming assignment as a computer science major at the University of British Columbia. And I went to lecture. Is that a shout out for UBC? Woo! And so scheme as well. So this was the first assignment that I was given. You go to lecture, you got your lab books, schematics of computation, and the assignment was to copy this code exactly as specified. I thought this was so awesome. I thought this was so cool. But this is not going to be interesting to everyone. And with Scratch, we see kids learning concepts through building, creating, and designing projects that they care about, that they have a lot of agency. And they've been creating a lot of projects since 2007. So there are more than 3.3 million projects on the site. About 2,000 projects get added to the site each day. And I wanted to just give you a sampling of some of the projects that kids have been creating. So this is a project by 12-year-old Connor. He wants to be either an engineer or a comedian. And he created a series of interactive joke projects. So you click on each box. Yeah. Connor. Okay, 10-year-old Robin loves drawing, and she was interested in Scratch as a way of displaying her creative work, and she used Scratch to create an interactive art gallery. 12-year-old Lindsay uses Scratch to make interactive animation and simulation projects, and in the online community, she organizes contests, creative coding contests. And so this was her entry to the contest on the theme of office supplies. This is a design your own office. But other contest themes have included ninjas and cute animals. The last project this is a game by 10-year-old Easton. He loves to play and make video games. And he thought that for Mother's Day, his mother would just love a custom video game. Yeah, so you press the space bar to navigate. This is me playing it. I'm not playing it very well. So his mother was at the interview that I did with Easton, and she remarked that the game is fun, but really, really hard. So in addition to building projects and exploring their understanding of concepts through building, kids are also learning concepts by helping other people learn concepts. And we see kids making tutorial projects for other kids. So for example, here's a project that explains how to use the trigonometric operator blocks. And the Scratcher in question has made numerous projects like this. And I asked her, like, okay, why do you do this? Why is this interesting? And she explained to me she does it because it supports her own learning. She said, they say that teaching is the highest form of learning or understanding. So I think that making math projects has actually helped me understand math concepts better than learning in school. Kids in the Scratch community also started their own wiki about Scratch and how to use Scratch. There are hundreds of articles, and this is just one of the articles. It's about recursion. So the graphical nature of Scratch enables kids to negotiate concepts, these powerful computer science concepts, without being bogged down by syntax. And this conceptual learning carries forward into future learning experiences. So we see kids next trying things like Alice, so they're drawn to the 3D nature. They try App Inventor, they're trying Flash ActionScript, they're trying Kodu, they're trying processing. In formal learning environments, Scratch is increasingly being used as the initial experience, which then transitions to another language. For example, at the college level, at Harvard, for example, David Malin teaches a course called CS50. Students do Scratch for a week, and then the next week they transition to C. Obviously, I know. Yeah. And yeah. So obviously at this venue, I would be remiss to not mention that Python is another hugely popular transition language for kids in the community and also in formal learning environments. And it's not even that you necessarily give up Scratch, it just becomes a part of your toolkit. So for example, one longtime Scratcher, he'd been working with Scratch for 6 years, he created a Python module for reading and writing Scratch project files. He then used Scratch to make a presentation about the module. So concepts, while good, are not enough. You actually need to put concepts into action, and you need practices and strategies for putting them into action. And my thinking about the strategies you need is very much motivated by Seymour Papert, so my mentor's mentor. And he had this beautiful way of describing it about learning and what you need to put it in action. So many children are held back in their learning because they have a model of learning in which you have either got it or got it wrong. But when you learn to program a computer, you almost never get it right the first time. The question to ask about the program is not whether it is right or wrong, but if it is fixable. And so he wrote this in 1980. I love that. That's great. So I'm fascinated by how kids negotiate that, how they go from here, a completely blank project, to here, their end vision, their grand vision. So I spent a lot of time asking kids, what's your process for fixing your programs? How do you get unstuck? And so I thought I'd share with you kids' top 6 problem-solving / debugging strategies and practices. I feel like this should be a type of Family Feud thing where you guess what they are, so we'll see how much overlap there is. So, okay, number 1 strategy recommended by kids when they get stuck, read through your code. So read through your project line by line, block by block, and ask, does this make sense? Is this doing what I think it should be doing? I'm like, okay, good first strategy. Second strategy. Try experimenting, try tinkering with your code. And the first time I heard this from a Scratcher, the Scratcher used an analogy, which actually worked very well for me. So 11-year-old Jensen compared Scratch project development to the tile-based word game Bananagrams. Are people familiar with Bananagrams, this game? I don't know. So he asked me, have you ever played the game Bananagrams? And at the time, I had actually just gone through like a horrible Bananagrams addiction phase. So I sort of like, yeah, I've played that once or twice. And so he explained to me, well, it's like Bananagrams. You get so far into the program or into the game, and then you realize, I've got these other letters. How do I get them in? You have to be able to take apart parts of your project and remix it up and put it back in. Next strategy. Sometimes you need to reorganize or rewrite your code. So here's one example. This is a project by 10-year-old Robin and co-authored by her younger brother. And the project, you navigate levels of a maze by flying around hazards and obstacles. And Robin was having a big problem with that character that was flying around, but everything, all of the code that controlled the character was just in one enormous stack, controlling every aspect, and she like couldn't parse it. So what she did is she decided to break up her code, and she separated it out into 3 sort of areas of interest. So she, instead of having this one giant stack, she had one stack that focused on the speed. She had another stack that focused on the appearance, and another stack that focused on collision detection and sensing. And this made it much easier for her to deal with and isolate the bug. So it was like, okay, reorganizing code, good strategy. 4th strategy, tell someone or ask someone about your problem. Kids talked about how just sometimes saying the problem out loud helped them solve it. I'm sure everyone has had that experience at some point, and you're just like, as soon as you finish saying, you're like, I know what I did wrong. But there's often more interaction and support that occurs between kids. So as I mentioned earlier, there are an enormous number of projects that are being shared on the website. The number of projects is completely dwarfed by the number of comments, and kids are using comments to interact with each other as audience, but also to get feedback. So here's one project. It's a puzzle project by a Scratcher named Silvershine. He thought it was pretty good, but he felt that it could be more awesome, was how he described it. So he posted the project and asked for feedback. What could I do with this? How do I get unstuck? I'm sort of feeling creatively stuck. So he got a response, and this is just an excerpt from the exchange. So Darth Pickley wrote, a pretty easy puzzle, but fun. Silvershine said, thank you. What do you think I could change to add a bit more of a challenge? And Darth Pickley recommended adding an additional feature. You know, you could add par of moves for each puzzle level. Kids also come together to establish more intentional partnerships to create projects that they couldn't have possibly created on their own. So for example, an 8-year-old, an 11-year-old, and a 13-year-old from different parts of the world teamed up to form what they called a production company. So one was the president, one was the lead programmer, one was the lead artist, and they recruited 30 other kids over the course of I know, levels of management. They recruited 30 other kids, and over the course of 3 months, they worked on an epic tribute to Halloween they call Night at Drury Castle. And I'll just show you an excerpt because the whole thing is huge, but it's choose your own adventure style. So you go in the front door. Do you open the door? Do you run away? Do you go in the basement, go up the stairs? So you go through this whole elaborate thing, but it was just amazing that, you know, none of the kids felt they could have done it on their own, but it was really about working with others collaboratively. I will leave that to you to find that on the Scratch website and do better than I did. So fifth strategy, look for examples that work. So kids were debugging their own problems by learning from others' code. As I mentioned earlier, you can look at the code of any project on the website to see how it was made, and then build on that code. A third of all projects on the website build on other projects. For example, side-scrolling games like Mario-style projects are enormously popular, but they're actually pretty tricky to implement in Scratch. So one community member, Archmage, developed a tutorial that explained how to do scrolling done right. And hundreds of Scratchers have built on this framework. If you can see at the bottom, 460 remixes by 291 people. And from this base, this is the original project explaining what it looks like and the code that you need. Kids have created adventure games. They've created interactive physics simulations that use scrolling as part of it. So this is exploring bouncing, but also art pieces. So this is like a free running, like parkour art piece, all using this side-scrolling mechanism. And if you look at the visualization of the original work and the derivative works, you just get a sense of connectedness and being able to build on other people's work. What I loved about the visualization when I looked at it, so Archmage's scrolling done right is in the center, but he's also, he made derivative projects based on his original work. So apparently scrolling can be done right, but it can also be done better. So 5 strategies, 1 to go. Last but certainly not least, sometimes you just need to take a break, which I thought was great. Every person I interviewed talked about the necessity of taking a break. Sometimes I get myself so dug in a hole that I have to just get myself out of Scratch for the day and then start it up another time. Because after a lot of programming, your head hurts. It's not easy to program with a hurting head. So the last dimension of learning that I wanted to discuss is this learning, this developing of perspectives, how kids start to see themselves and the world around them in new ways. And the psychoanalyst D.W. Winnicott has this beautiful phrase about the importance of a sense of creativity in our lives that I wanted to share. It is creative apperception more than anything else that makes the individual feel that life is worth living. And so part of the goal, the vision, the aspiration for Scratch is to support kids' sense of creative self-expression, of possibility. So, for example, 12-year-old Lindsay described it as, it's really great to express yourself creatively. You could do anything with it. You can make video games, music, art, anything. The possibilities are endless, no limitations, really. Kids describe themselves as capable of great things. So this is language that kids use to describe themselves. I love the challenge. I was persistent. I had a 3rd grader tell me that she has grit, which I loved. I'm like, that is fantastic. It gives you that sense of accomplishment when you finally finish your project. It boosts your confidence when you finish something that you never thought was possible. So it's about kids seeing themselves differently, but also seeing the world around them differently. And this next quote sort of captures both. Now I have what I call a programmer's mind. That is where I think about how anything is programmed that has gone from toasters, car electrical systems, and so much more. And so this idea of seeing anything is up for grabs, as anything that you can remix, that you can modify, that you can change. Kids are even doing that to Scratch itself, which I think was one of the most exciting things that happened. So this is Panther. It's a Scratch derivative that adds numerous advanced features that the kids really, really wanted, and we were reluctant to add because it was going to make the floor less low. So returning to the original question, what are kids learning? I've shared a little bit. We've done a tour of kids and how they've been learning computer science concepts, how they've been learning design and problem-solving practices, and how they've been developing psychological and technological perspectives, new ways of seeing themselves and the world. But I guess what I wanted to end on was that more than learning concepts and learning practices and learning perspectives, fundamentally, this is about kids learning. despite what happens in many school settings, this is not learning. Learning is not just being filled up with information. Despite what is happening in a lot of design of online learning systems, like MOOC craze, learning is not this. It's not just broadcast. And I wanted to end with what I hope learning should be, with a quote from Bradley, a 12-year-old Scratcher. I really loved what he had to say. So Scratch lets you explore your imagination. You design your own stuff, and once you start, you just don't want to stop. Because as you learn more, you can see there are more possibilities. And the more possibilities there are, the more you want to expand on what you just learned. And I think this is what we hope for all learners. Thank you.
Thank you, Karen.
So I wanted to make sure, is it okay if I do something a little different?
Go.
Okay, so I tried to keep my talk short-ish because I wanted to leave time for discussion. So questions, reflections, suggestions. So if you're game, what I was hoping we could do is that you could have like 5 minutes with your neighbor to like discuss, and then we come back as a whole group. Does that work? Okay, thank you. Okay, so I'm gonna put a timer, 5 minutes up, just to give you a visual prompt, and then we'll come back as a whole group and we'll just open it up. Okay, let's go, 5 minutes.
Okay, so we're kind of bootstrapping this from first principles here. So Karen is gonna stand up at the question mic here. I think we're gonna have to turn it around though, so you're not, because that's a bit weird. Yeah, and if somebody wants to say something or make a point, I'm gonna run the mic over to you, and then she'll talk to you on the floor here. The wireless mic was getting a little bit restraining, so yeah, I totally get it. So is there anybody who would like to ask Karen a question or have a point of discussion? You were very eager to talk, so if you could just introduce yourself and go from there.
Hi, my name is Artem, and thank you, that was a great talk. And I introduced my daughter to Scratch a few years ago. She's 11 now, and she's been a huge fan. And thank you very much, my personal thank you for that. And but lately she was a little bit distracted by that little game called Minecraft. You probably heard of that.
I think it's a fact.
Yeah, and so and she's been doing kind of not a real programming, but sort of customizing this game and writing little macros and scripts. And if I extend your metaphor, it's probably already having a ceiling, but probably like painting it with flowers or something. It's more like that. So I was wondering if you see some merit in this kind of learning, already having a sort of rich computational world like Minecraft, and starting with customizing little details and going with more and more complicated scripts and customization with that. Do you see it has some merit? Thank you.
Yeah, Minecraft is insanely popular with the kids in the Scratch online community, and we actually at MIT a few weeks ago, we all got together and just played Minecraft for the afternoon, because it's ridiculous that we don't know anything about it and all the kids are building and playing with it. So I think my general policy is that any activity in which people are designing, making, creating, playing is a good thing. And different environments have different affordances, right? You have more structure, you have less structure. And so I think in general it's good. I'm always interested in sort of the trajectories, the pathways in and out. So, she was into Scratch, she's into Minecraft. What's going to be next? Is she going to go back to Scratch? Is she going to be like crazy Python aficionado? You know what I mean? So you never know what's going to happen next. So it's, it doesn't seem like creativity never seems like a bad thing to me, I guess is the short answer. Thank you.
We had somebody else who was so eager that he came up to me, so here you go. Just introduce yourself.
Hi, my name is Antoine. I was told by the lady to come here. So, when I read about research like that, I've always find it very interesting, but I'm always curious about the sample, like how many people, how many child did you interview? What was their background? Were all their parents programmers or?
Yes. Yeah.
So I'd like to know more about that.
Okay, yeah. So, yes. So this is work that was pulled from my dissertation. So I interviewed interviewed 50 kids several times over a 5-year period just to sort of like keep track of what they were doing. And they were a very diverse sample. So, actually when I first joined the Media Lab, I had come from a school of education and I was interested in what kids were doing with Scratch. So I arrived in 2007, August 2007. I show up on the doorstep of Media Lab. They had just launched the authoring environment. They had just launched the online community. So in many ways, a lot of the hard work was done. So it was kind of a nice time to show up. I had the luxury of sort of seeing it get out in the world and talk to kids about what they were doing. So when I first started interviewing kids, this is like September through December of 2007, I'd say, oh, how did you find Scratch? And like, oh, my mom showed me, my dad showed me, my aunt showed me, whatever. Oh, what do they do? They're computer scientists, they're engineers. I'm like, whoa, whoa, whoa. You were probably gonna have a good experience with technology one way or another. You probably don't need Scratch for this. How do we broaden participation? So actually something I didn't talk about at all this morning was what my research is primarily focused on, is broadening participation. So my approach is to teach teachers about Scratch and then to get it into school. So that way you don't just have this effect that like, you are all wonderful, lovely people. You have a lot of preparatory privilege if you have kids that you're introducing Scratch to, right? So how do you get Scratch in the hands of kids who don't necessarily have programmers at home, or computer engineers or whatever it is? And so that's been a big strand in addition to talking to kids. So the sample that you saw here, there are some kids who have, my mom is a programmer, my dad's a programmer, but there are also a lot of kids who when I talk to their parents, they're like, I have no idea what this is. Can you explain to me what my child is doing? Is this good or bad? Or, and so it's a range, So.
Thank you. Would you like to?
Hi, I'm Dennis. And my question is that many different schools use different programming languages to teach computer science. And you mentioned that CS50 starts with Scratch and then transitions to C.
Yes.
And I'm just wondering how this was decided. Is there any research that suggests these are good starting languages? I'm not saying it should be different. I'm just saying that different schools use different languages. I'm just wondering if there's a good language that should be used to start out with.
It's incredibly contested. No one agrees on, that's the one thing we can agree on is no one agrees. And different languages have different affordances. And so I think, the case that I shared with David Malin, he was really interested in gender participation because he was teaching this course and women were dropping out like crazy. And he's like, okay, this is not tenable. We can't keep up this way. And so he was experimenting with different things and since he's just down the street and knows Mitch, he was like, oh, why don't we try, starting out with what you can make with it. The first week of C is not exciting in terms of things you can create. It doesn't feel very empowering. So it's like, hey, you get to engage with some big computer science ideas in a week with Scratch, but you get to make whatever you want. And so he actually did a longitudinal study of the impact of starting with Scratch, and it significantly increased retention over time and sort of who continued to enroll in the computer science major, particularly around gender, and also recruitment, because the word got out that hey, computer science doesn't suck, which was pretty exciting. So there was this possibility and this potential, and so. But I think what I really love about it, as complicated as it is, that there's so many different ways of getting started. I like that diversity because it is a diverse, messy ecosystem, and to say that there's the one way to start, I don't think reflects the day-to-day practices of what people do. So that's sort of a non-answer, but it's messy, but I think it's good it's messy, and there are benefits and problems with starting with different languages.
Hi, I'm Jeff. I'm curious, what has been discovered as far as when children have learned Scratch or Alice or something, and then they go to transition to actually writing code? Do they have to relearn everything, or does the knowledge actually translate well for them?
Yeah, so there's actually a lot of translation. So there have been some small studies of classrooms. You're studying 30 or 60 kids in relation to the CSAP exam. Do you have an equivalent thing here? No, okay. So, so what happened when they were doing half a term of Scratch and then doing half a term of Java? It's not a matter of relearning everything. It's just with Scratch, with Alice, you're just not bogged down in the syntax. You don't have to worry about semicolons. So it allows you to focus on the big conceptual ideas without worrying about, because it's really, there have been some really fascinating studies of what kids' misconceptions with text-based languages that, they'll be missing. The punchline of this research is often kids don't read like compiler errors. So they're like, there are some clues there about like what's wrong, but they'll think it's like something wrong with their model of how they're translating what's in their head into what's in the code, but it's actually like a really small error. So they'll spend all of this time writing their code. It's like 99% correct. They're just missing a semicolon or something really minor. And then it doesn't compile, they don't read the errors, and then they're like, oh no, I totally have it wrong, so they rip everything apart. Like, so it's like, and what a waste, right? Get rid of the syntax concerns, focus on the big ideas. You can program lots of interesting things with like graphical programming languages. You get the foundations, and then you can carry those over. A variable is a variable is a variable is a variable, whether it's in Scratch or whatever language. And so you get that powerful idea without worrying about, int x, semicolon, whatever, So
Python's definitively the right language.
I love this crowd and its propensity for self-congratulation. Huge round of applause for you.
Hi, Karen. Thanks for the talk. I'm Dan. I have a 7-year-old daughter, so I'm really interested in a lot of aspects of this. She's played with Squeak, and she's enjoyed that. I'm wondering a couple of things. One, with the focus on sharing that the Scratch community has, is there a veiled attempt to try and grow a whole generation of open source coders from the beginning? Which would be awesome. And I am interested to see if there's a thought that sort of natural sharing is going to continue. And I'm also interested in, with a language like Python, where doc strings are built into it, and in a sharing environment where comments and documentation are very important. Does Scratch support that sort of a sharing, or is most of it sort of build another Scratch project to describe the project that you've written elsewhere?
That's very meta. Yeah. Okay, there were a couple of questions. So the agenda about open source, are build it from the ground up. So sharing is a huge part of the culture, and we are trying to push on kids' conceptions of ownership and authorship. And it's hard. There is like a lot of culture is operating against us. A lot of so when we first launched the site, you could download people's projects, remix it, and re-upload it, and kids were just incensed. They were incensed, like, Dan copied my project and he didn't give me credit, and it was just like, oh my God, this makes no sense. Why are you so upset? This is a great thing. And you have this indicator of like your work built on my work. So actually there was like a long campaign of winning hearts and minds with the kids to sort of explain like, no, look at how much benefit you derive from this. Look at the collective awesomeness. And so it really took time with the community for remixing as an idea to build cultural capital, because everywhere else they go, or not everywhere, but like many other places they go, school, a major offender of like sharing of work is strongly discouraged, right? It's copying, it's plagiarism, whatever. So that's a challenge. But kids, when they get it, they are on board, they're passionate about it, they expect it elsewhere, which is so I guess that's part of the like trying to seep out into culture more broadly. So that was your first question. The second question about documentation, yeah, it's not as cool as Python. Some small things. So you can comment your code. Some kids do that. So you can actually add comments and attach it to stacks. I don't think any of the examples I showed had comments. It's bad on me, shame on me. You can also provide some sort of meta documentation, so you can have instructions for a project, you can have notes and attribution actually, which connects back to your question about credit and like remix culture, that kids, even though there's this automatic attribution of credit with computation, one of my colleagues, Andres, who was a doctoral student at the Media Lab and is now at Microsoft Research, did this interesting study of like kids' attitudes towards automatic versus like human generated credit. And this is probably not shocking that like kids were much happier when someone took the time to elaborately praise and credit them, or even not so elaborately, just like rather than just the machine doing it automatically, saying like, oh, it builds on your work. So yes, but I think there's more that could be done with documentation and notes.
Hi, Karen. My name is Mario. I found your talk really inspiring. I'd like to hear success stories or strategies for introducing Scratch into elementary school curriculum, particularly with respect to who the right people to talk to, whether it's like at the superintendent level or at the school board level or teacher level or student level, to try to bring that in. I'm very interested in that.
Oh, that's great. So, yeah, as I mentioned, I'm like really a big focus of my work has been on working with teachers. So I built a companion website a few years ago called Scratch Ed. And because teachers were looking at the Scratch website and they were excited and they saw all this possibility, but they didn't see themselves in it. You know, like teachers aren't making Scratch projects. They want to help other people make Scratch projects. So they're like, what do I do with this? So I built a website and a place where teachers can share stories and exchange resources and ask and answer questions. So checking out Scratch Ed is one way of doing it, because there are, you know, middle school and upper elementary is sort of the sweet spot for Scratch. You know, upper, like when you get into high school kids, it's like not cool enough. You know, that cat is like just not, it's like you can get rid of the cat. But, and then it comes back into vogue again in college, because college kids sort of treat it ironically. I don't know. It's a whole process. So check out Scratch Ed would be one advice. As for actually strategies, I feel like Scratch has benefited really from like a grassroots approach. So like we don't do a lot of stuff top down. You know, like of the 9,000 teachers who are on Scratch Ed, it's mostly teachers rather than superintendents and stuff like that, because teachers are like in the classroom, they're having the face-to-face with the kids. But I love that you mentioned kids, because they've been a huge ally for us in getting Scratch into schools. Like they find it on their own. They're like Googling, like, how do you make your own game? Scratch pops up, they do it, and they're like, they bring it. They bring it to the school. They demand that they be allowed to work with it. So that's been like a nice surprising thing where kids are teaching their teachers how to use it. And then the teacher's like, oh yeah, I see the possibility, and I see how insanely, rabidly passionate you are, and I'm kind of scared of you, so let's do it, you know? So it's like, it all works out. Thank you. Okay. So.
One of the things that struck me about the Scratch interface is you can have simple instructions and you immediately see the feedback, what happens in the animation panel. And that short feedback loop seems to be very important in a learning environment. And something about Python, I know I always drop into the interpreter to test out a line of code, even just to see if I have remembered what the methods are, rather than, this is faster than Googling for docs. But I'm wondering, this short feedback cycle in learning of programming, how important do you think this is? Is this something that you've seen important in taking up these sorts of technologies?
Yeah, I'm glad you brought that up. Actually, that's a key design principle of Scratch, so that we have a few guiding principles, and tinkerability is one of them for that very reason that you described, that you have that, like you can't, you need to support being iterative and incremental in design. And the best way to do that, just drag it out, test it out, try it out. That was just like essentially important. And even from the sort of like the cognitive science research, we know that having that instantaneous feedback rather than trying to like deal with a massive system in 2 hours from now, like just does not work, particularly for people who are getting started. Because you need to sort of wrestle with the building up of that mental model. So yeah, I love that you brought that up, because that is something that's really important to the design.
Hi, my name is Yulia. I'm doing currently research in terms of students' misconceptions in upper CS courses. So when you mentioned misconceptions, I just clicked. And so my question is, what kind of misconceptions did kids tend to have? And what kind of misconception get transferred or not transferred to, say, like Java when you mentioned that study? What did transfer, what did not? What appeared new that wasn't covered by Scratch? That's
a great question. So my head is suddenly flooded with misconceptions. I'm trying to like pick one interesting one. So probably the biggest misconception that also kids and adults when first encountering Scratch, adult non-programmers, is the fact that it supports parallel execution. That just like makes no sense, because there's just such a strongly ingrained timeline culture of like this, then that, and so that really messes them up. And then translating into other languages, that's, yeah, where there are different models of how parallel execution happens or not. that's where some of that stumbling happens. So probably, yeah, parallel execute. If I had to pick just one, but I could go on and on, but I will stick to parallelism.
Hi. I'm just wondering, has a text-based approach been taken to teaching kids programming? And if so, has that worked? If it hasn't worked, is it because we're in an environment that has constant stimulation, so we need to see, videos or images all the time in order to be stimulated and interested? Because most of us in this room have probably learned programming through a book, manuals, and we've done well through that, I think. And and I'm just wondering if that approach can be used on kids, or is it just a lost cause now, given the environment that we're in?
This feels like a really loaded question. I'm like about to pass judgment on modern society. So how can I not get myself into trouble here? Okay, so clearly you can start with a text-based language. As you pointed out, this room is a testament to that. So the challenge, as I mentioned, and actually even sort of Scratch's predecessor logo was text-based. And the challenge was this like syntax was such a stumbling block. So with Scratch, the blocks is less about sort of like the visual sassiness, shall I say, of the graphical user interface. I think it's less that. It's more about like, how do we relieve some of the cognitive burden for beginners that like, no, you don't have to worry about whether you spelt it MOVE or if you spelled it MVE or MVEO. It's like you've done something silly. Like it's like just take that off the table, and it just like gives you some time to focus on one aspect, or it's like at least one less aspect of the complexity of learning how to program. That doesn't mean that, yeah, there's obviously some value in it, but I think as I mentioned, there are lots of things that computer science education is doing badly, and the lack of diversity. But I say that with all the love in my heart. I do. Like, it's doing a lot of good things, but it's also doing a lot of bad things. And so I think the lack of diversity in the field is a pointer to that we don't do computer science education as well as we could. So why not avail of ourselves of every opportunity we have to invite more people in? And if it's a matter of getting rid of some of that like syntax stickiness at the beginning, let's do it. And then, yeah, we'll move. Because like doing workshops with professional programmers around Scratch is hilarious, because like the rage that starts to ensue as programs get complicated, because yeah, graphical programming languages like only scale to a certain extent, and people get really frustrated. They're like, where's my textual representation? And so the kids also get to that point as well. And I'm like, maybe this is a good time to try another language. Have you seen Python? It's like, this is there are different transition points. So yes, graphical, I think there will always be audience for text-based languages. Graphical programming languages are just a way of inviting more people into the conversation.
So this is going to have to be our last question. I'd invite, I know this is an exciting topic for everybody, and I imagine a lot of people are going to have questions of Karen after the talk. So if it's cool with you, maybe we could take that outside where the buff boards are out there, and continue that outside, because we're going to have a talk here in a few minutes. But
cool, just a follow-on comment. I saw a presentation where a gentleman had taught his son how to program in Scratch, Python, and C#, which was an interesting choice.
The obvious triplet, yeah.
Right, and so the presentation included his son reproducing code that he had written and printed out beforehand, just retyping it, rebuilding it in front of the audience live, which made me realize that actually being able to type is a huge barrier to being able to use Python. The kid understood algorithms, understood looping, but couldn't actually type quickly enough to express himself. Whereas when we sat down with Scratch and did the same thing, it was just, you've seen kids play with Legos. It's just snapping together. Click, 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 and he had his program. And I was wondering if that decision to avoid typing was something that was conscious in Scratch's development, or if it was kind of an ancillary benefit of using the visual metaphor.
No, it was very intentional. I mean, when we were initially talking with kids about what would you need, in a programming language? Okay, this is what a programming language is. This is how it currently works. This is how it could work. What would you need? That just seeing kids, and again, building on the logo research for decades, just tripping over typing. It just seemed like such a waste of energy. It made no sense. So yeah, having that visual metaphor was very intentional to get rid of the syntax, to get rid of the typing, and they'll get to that point when they're ready. Thank you.
Thank you, Karen. And let's give her a big round of applause. That was awesome.